Hi class! In today's video notes we're going to be talking about scatter plots, and we're going to be analyzing them and making observations and then drawing what's called the line of best fit. So to get started, a scatter plot is a graph that illustrates the relationship between two sets of data represented by two variables. The scatter plots are composed of dots, or what we call points, on a set of coordinate plane. And then we don't actually connect the dots. So if we're looking at this graph that we have right here, we can see that the title of the graph is Diamond Prices. And then we have carats, which is a way of identifying how nice a diamond is. And then on our y-axis, we have the price. So it kind of makes sense that as the carats are going up and you're getting a nicer diamond, the more expensive that diamond is going to be. And we can see what's called a positive correlation in this graph, because as x is going up, so is y. Y is also going up. And we can see that because this trend is showing that the more carats you have, the more expensive it is. So in a scatter plot, each point can be represented by the independent and dependent variable, which makes sense because it's dealing with x values and y values. And we know those are independent and dependent. And then you can pick a specific point. So let's say I pick this point right here, which is at like 2.6 carats maybe, and it's about $16,000. So you can read a point based off of what the x value is and what the y value is. So there's different types of relationships that we're going to be identifying in a scatter plot. There's relationships for pretty much anything you can think of. For example, there's height and weight, where weight would be on the y-axis and height could be on the x-axis. And then there's different types of correlations that we can see happening within those scatter plots. As I showed previously, we have a positive one, and those are lines that are going up, because as x is increasing, so is y, so they're rising. And then we also have negative correlations, or negative relationships, that on our coordinate plane, they're lines that are going down, because as x is increasing, y is decreasing. So a linear relationship between variables does not necessarily have to have a connection. For example, as the temperature at the beach is increasing, the sales at an ice cream shop are increasing. If data were collected for these two variables, a positive linear relationship could exist. However, there's no connecting relationship between the variables. The temperature outside does not cause the increase in ice cream sales, but there is a relationship between the two things. And this is what we call, and you'll hear this quite a bit, is that correlation does not mean causation. So just because two things are correlated with each other, like temperatures and ice cream sales, it doesn't mean they affect each other. So in these graphs that we have right here, we have three different types of relationships that we're going to be identifying. In the green one, we can see that as x is increasing, meaning going to the right, the y values are also increasing because they're going up. So looking at the trend of the dots that we have right here, we can draw a line that is going up, and we can call this a positive relationship or positive correlation. In the second graph, as x is increasing, so the dots are going more to the right, we can see that the data points are going down. We can take 2 points, for example. We could take this point right here and this point right here and see that the further right that I get, the lower I am getting. So this is called a negative correlation. In this last graph that we have right here, I can't really say anything about it. As x is going to the right, y is kind of going all over the place. We can't really make any predictions. So this would have no correlation at all. They're just kind of random dots put together. And some things just aren't correlated. So you might have a graph that just you can't make any predictions off of, which is perfectly fine as well. So in these examples, let's determine if the type of relationship is positive, negative, or no correlation at all. So in this first example, the size of a home versus the size of its lot. What do you think? For this example, I could have a giant lot and a tiny house on it, or I could have a small lot with a big house on it, or I could have a big lot with a big house on it. So I could have any number of situations come out of this, so there's no correlation happening here. In example number 2, the number of passengers on a plane versus the number of suitcases. So let's say we had a graph here. We had passengers on one end and suitcases on the other. So thinking about, as my passengers are increasing, what's going to be happening to my suitcases? What kind of relationship do you think these two things have? Well, it would make sense that as the number of passengers is going up, the more suitcases are going to be on that plane. So we're going to have something that looks like that, which has a positive correlation. Remember, correlation does not mean causation. The number of days in fall versus the number of leaves on a tree. So as fall continues on and we go from September to October to November, thinking about the number of leaves that we have on a tree, seems like we start with a lot of leaves and then we progressively get less as fall goes on. So what kind of relationship would this be? Well, since my y value is going down as my x value is increasing, this would be a negative correlation, because as x increases, y is decreasing. So now we have to do something which is called the line of best fit. And in a scatter plot, it's used to help predict what could happen or estimate something within our data set. So the line of best fit is a straight line which may or may not pass through individual data points, but it basically helps show what the data is doing. So you can see all of these individual data points that we have here. When we draw this line of best fit, it's basically showing us that, okay, I see I have a positive correlation because as x is increasing, y is increasing. And this is roughly what our data is doing. So if I wanted to pick out a certain data point within our set, where I could say, all right, at 6 hours of studying, I should roughly get an 80 on my exam. That helps us predict it. Or if I'm thinking about 10 hours, which doesn't have a data point, it can help us predict what would happen. And roughly, if I did 10 hours of studying, I would get roughly a 100 on my exam. So lines of best fit are really cool for predicting data points within what we know, or predicting things outside of our line that we have here. So here we have the number of hours a student studied for a test and their grade. So the hours are going to be our x-axis, and grade is going to be our y-axis. And we need to plot these different data points that we have here. So we're going to label our x and y axes with what we know. So hours is on the x, so we're going to have it go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then on our y, we're going to have different points as well. So we're going to go by tens. And now for each of these data points, we just treat it like an ordered pair. So the first point that I'm going to plot is 380. So I'm going to go right 3 and up 80 and plot that point. And I'm going to do the same for the rest of the data points that we have here. I'm going to go 5 to the right and up to 90, 2 to the right and 45, 6 and 85. And all I'm doing is just plotting these ordered pairs that we have from the data set that we were given. Go ahead and pause here and finish the rest of them. So now we've gone ahead and plotted the rest of the data points that we were given, and we need to use a line of best fit to roughly get an idea of what's going on. Now you can only use a line of best fit when you actually have a correlation. So if I have no correlation, I can't do a line of best fit. But in this situation, we can see that as x is increasing or going to the right, our y is also increasing and going up, meaning that the more hours I study, the better my grade is going to be. And we can draw a line of best fit that roughly goes through our data directly in the middle to give us a correlation idea. So we know that it has a positive correlation. And we could see that if I studied for 1 hour, I would roughly get a 55. At 4 hours, I could roughly get a 70. At 6 hours, I could roughly get a 90, and so on and so forth. That's what that line of best fit is good for. We're going to do the same exact idea here, the number of hours that a person spent at a mall and the amount of money that they spent. So we're going to have hours on the bottom here. So here we have our hours, and then we have our dollars. So we're going to do the same idea of just plotting these points that we have using our ordered pairs that were given. And it looks like we're going from a minimum of 15 all the way up to 115. So I'm still probably going to go by tens to make sure that it all fits. All right, go ahead and pause here and fill in your data points, and let's see what kind of relationship we can find. All right, we have gone ahead and plot each of these data points. And if I were to read one of these data points, like let's say this one right here, this would read as the fact that I spent 5 hours at the mall and spent $70. So now let's think about the relationship. What kind of correlation do we see with this graph? Based off of what I see right here, I can't make any correlation or relationship. I don't see anything because I could have spent 1 hour and spent $40, or this guy that spent 8 hours and only spent $25. There's no way I could predict what would happen, so there's no correlation or no relationship. We're going to do the same idea here. We're going to have years and the number of homes with a landline. So we have years and then homes with landlines. I don't even know if you guys know what that is anymore. Landline is a phone that was connected directly to your house rather than a cell phone that you can carry anywhere. So here we have our different years. So I'm just going to write the last 2 digits of them. So 0, 0. Actually, 0, 0 can go on our axis here. So I'm going to erase that. 0, 0 is on our axis. And then we can go by 2s each time. So this is going to be 02, 04, 06, 08, 10, 12, 14, 16. And then our numbers, I'm probably going to go by tens again. Just trying to find a good scale so we can see what is happening to the data, but make sure all the data points fit. So the first one is going to be 0, 0, 84. So I'm going to be on my x-axis and go up to 84 and plot that first point. And then continue on at 02. I'm going to be at 80. I'm going to have you pause here and finish the rest of the points. Well, this data set that we see here almost makes a line of best fit for us, which kind of clues us into what type of relationship we have. So if I were to draw my line of best fit, here it is. So then what kind of correlation do we have here with the years compared to the number of homes with a landline? Since our x is increasing and our y is decreasing, this would be a negative correlation. So now we have to analyze what's going on here. So a company's stock price is here, and it's listed since it launched in 2006. So for question A, it says, what is the approximate stock price in 2015? So the way to read this is we look down here where it says year. In 2015, we know is between 2014 and 2016. And then to find that value, it's going to be this data point, which would match up with roughly $21 or $22. So I'm going to say $21. So that's how we would read this graph. So then we could be asked a question like in B, where it says, in what year or years was the stock price $35 a share? So the way to figure that out is we go on our y-axis and look at where 35 is and try to see what years those data points were happening. What do you think? Well, we can see that the 2 data points that are lining up with our 35 are at 2010 and 2012. So there were 2 years that was happening. And now based off of what we can see here, we need to determine, is this a positive, negative, or no correlation between what we have? Well, we can see that as X is increasing, or the years are going by, the stock price looks like it's going down, which is not what you want to see as a company. You'd want to be able to see it going up because that means you're being more successful. So unfortunately for this company, it has a negative correlation because as years have gone by, the money that they get per stock share is going down. Now we have another example of Olivia who bought a used car in April, and the graph shows the odometer reading after each month. The odometer is how many miles are on your car. So here we have an example of that graph. So we have the months as our x-axis and the odometer reading, which is the miles on the car. So approximately how many miles were on the car when she bought it? Well, that would be at year 0. So here we have year 0 when she bought it. And the data point that lines up with that is right here. So it's going, it looks by 2s here. So it's in between 2 and 4, and it's in thousands of miles. So it didn't just have 3 miles on it, it had 3,000 miles on it, which is not a lot for a car, so that's great that she bought it. And then we're being asked approximately how many miles were on the car in July. So thinking about July, let's count our months. January is 1, February, March, April, May, June, July. July is the 7th month. So thinking about that, how many miles were roughly on her car? Well, since it's the 7th month, I would go over to between 6 and 8, and the data point that correlates with that one is right here. And we know that this is 10, so it's between 10 and 12, which would be 11,000, remembering our unit on the y-axis. And then the last question we have to answer here is, in what month did her car reach 14,000 miles? So for this problem, we have to look at our y-axis first and think about where that would be. So if we're looking for 14,000, we know that's between 12 and 16 right here. So the point that it reached that would be this month right here. And thinking back to our numbers, that's showing at 9, and that would be in September. Now, a question that wasn't on here that you very easily could be asked is, what kind of correlation do we see? And we see a positive correlation happening because as the months are increasing, so are the odometer readings, and you have more miles on your car the longer you drive it.